Hi students, in this video we're going to look at how to solve quadratics by completing the square. So after watching this video you should be able to understand that partially factorizing a quadratic actually makes it a little bit easier to solve. After that you should be able to solve quadratics by completing the square, and also we want to talk about why some quadratics cannot be solved using real numbers, how we get to that situation and how we can tell it's occurring, and think about why is it that some quadratics can't actually be solved. All right, big things we have to recall. We want to remember that solving means determining a value for an unknown. So finding out what number x equals. We'll need to remember a bit about how to complete the square. So do a bit of revision on that if you haven't already. And we also want to remember that the square root of a number can be positive or it could be negative. And that'll be really important as we go through. All right, now when we partially factorize a quadratic by completing the square, the truth is it makes it much easier to solve, especially if the quadratic cannot be factorized. Now the main reason this is the case is because in standard form, we might have a x value in two places. We can't rearrange this equation and get x on its own, it just doesn't work. Now, what we can do though, is if we've got, that's not quite right, if we've got x plus 3 squared minus 13, okay, this equation we can rearrange. We can plus 13 to both sides to get rid of that. We can then square root both sides to get rid of the squared, and then minus 3 after that. Because x occurs in only one spot, when we partially factorize, it makes it much easier to rearrange and solve. And it's that idea that helps us solve quadratics by completing the square. Now, our steps for solving quadratics by completing the square, we want to rearrange our equation so all of the variables are on one side and the constant is on the other. Now, you could make it equal 0 and do largely the same thing. That's totally okay, but you don't really have to make one side equals 0 if you don't want to. The key thing is all of the variables, so your x squared terms and your x terms, need to be on one side and your constant on the other. Add half b squared to both sides. Again, that's just something from completing the square. We'll talk about that again. Factorize using the perfect squares rule, and then finally rearrange. And so we've got 4 steps there. I'll go through them with you as we do a couple of problems. All right, this first one. We've got to solve the equation x squared plus 4x equals 2. Now our first step here is already done for us. We've got our x squared term and our x terms on one side, our constant on the other. If we want to, we could move the 2 over, but when we're solving, that's something we don't really have to do. Now what we have to do next is add half b squared to both sides. Okay, add half b squared to both sides. So just remembering what is b. B is the coefficient of our x term. So here we've got b equals 4. Now we want to add half b squared. Okay, so half b squared, so half of 4 is 2, and squared is 4. So what I want to do is add 4 to both sides. So my equation becomes x squared plus 4x plus 4 equals 6. So adding 4 to both sides, that 4 came from halving our b value, half of 4 is 2, and squaring it to make 4. All right, that's our second step done. Our next step is to factorize according to our perfect square rule. Now our perfect square rule was if you have a plus b squared, that equals a squared plus 2ab plus b squared. So in this situation, we've got a equals x in this case. And at the back here, the term we're adding on, 4 is our b squared value. So that means in this case, b is 2. A little bit confusing with b and b, but that's just how the notation works as we go through. And then in the middle, we've got a times x times 2, which is 2x, and then we double it to get 4x. So this rule that we're about to use can work, and it can only work because we added b over 2 squared to both sides. So when it factorizes, we get x, and we have a plus there, so that'll be a plus, and then a 2 on the end. So x plus 2 squared equals 6. And now that I can rearrange. So going up to this side, I'll rearrange both sides by square rooting. So x plus 2 equals plus or minus square root 6. Don't forget your plus or minus sign. Right, the square root could be positive, it could be negative. We need to include both. Then finally, last step of rearranging, we'll take 2 from both sides. So our value for x is negative 2 plus or minus the square root of 6. And there's our two solutions. So x could equal negative 2 plus square root 6, or x could equal negative 2 minus square root 6. And those are the two solutions for this particular equation. Key thing is, guys, again, making sure you add your half of b squared to both sides, and then going from there to your factorizing step, where you can turn it into x because you've got x squared, and then whatever the square root of 4 or the number you add on is. All right, this next one, we've got x squared plus 10 equals 3x. Now we do need to do some rearranging here because we want all of our x terms on one side and our numbers on the other. So I'll subtract 3x from both sides and subtract 10 from both sides. So we get x squared minus 3x equals negative 10. Now from there, we need to work out our half b squared value. So b in this case is going to be negative 3. So half b squared, half of negative 3 over 2 is just, well, negative 3 over 2, that's half, and then squared. Negative 3 squared is 9, 2 squared is 4, so 9 over 4. All right, so we're going to add that to both sides. X squared minus 3x plus, on this left-hand side, I'm just going to write negative 3 over 2 squared, just to remind myself this is the part I want in my brackets when I factorize. But on the other side, I might write it as 9 over 4 because that's easier to add to negative 10. So negative 3 over 2 squared is better to help me factorize. So when I get to this step, it will be x minus 3 on 2 squared, and negative 10 plus 9 on 4. Negative 10 is negative 40 on 4, which will be negative 31 over 4. Negative 40 plus 9 is negative 31 on 4. All right, now the next step, guys, we just keep rearranging. So I can square root both sides, plus or minus square root, negative 31 over 4. Now at this point, we can stop because this equation can't be solved. And how we know that is in here, right? We know that we can't square root a negative number. Right? We can't take the square root of a negative number with real numbers. It's not possible. So what that means is if we get a situation like this where we have to end up square rooting a negative, that's not possible. So therefore, this is not solvable. Or there are no solutions. okay, to this particular equation. It just can't be solved. We don't have any numbers that make this equation work. So that's the situation we should look out for. If you ever have the square root of negative, that means we can't solve the equation because we can't square root a negative. Right, students, so after watching this video, you should be able to understand that partially factorizing a quadratic makes it easier to solve because x is only in one spot, not two, and that's easier to rearrange. So we can solve quadratics by completing the square. We did a couple of examples of that, and understand why some quadratics can't be solved using real numbers. That was the last example we did, showing that we can't square root a negative number, making some quadratics not solvable.